How amazing will it be to get this effect on a modern screen in Raylib, in C#. And it's not only the CRT effect, it's a full post-processing stack that I'm going to explain how to implement. Are you interested? Then come along. But before I going to explain, let me first tell you a story. If you are not interested in a small story, then please skip along. I have timestamps here in the video. Then I will see you there. But also a small remark on the implementation part. There is no game engine needed. You can just implement it in the way that you want. All right, but the story. This monitor is a monitor from the 80s. It's a Commodore from 1984, if I can remember correctly. And you know what is funny? I bought this one on vacation, and it has one amazing feature: to annoy your friends. Yes, I am strange. I'm bringing old stuff to vacation homes. But they were playing, I think, Super Mario, because I can also hook this one on the Super Nintendo. And there is here a setting, and if I am rotating it, then you can see it's scrolling all the time. Try now to finish your level. It's just so funny. I really love this monitor. Now that's out of the way, allow me to explain how this is going to work.
So we have indeed processing the games and the CRT effect. But yeah, the question is indeed how. And well, basically, imagine you have a game like Snake. Then you have your drawing logic. Then you do it directly to the screen buffer most of the time. But we need to do this different. And basically, if you have the Snake game again, first we need to render everything to a render target. So everything will be in that buffer first. We are not going to render it directly to the screen buffer. And then we have the post-processing step, which can be a manager or something, and it will apply all the shaders. But you can also see that we are stacking those shaders, because in post-processing, we are applying multiple effects. And then, when everything is done, then we copy the final result to the screen buffer. But you're probably going to ask, how do we stack? Well, by swapping the layers, because we make two render targets. Basically, render target 1, render target 2. Then we're calling it ping-pong, and no reference to the pong. But you have then, for example, first you do the color grading, then you do the screen warp, then you do the bloom, then you do the vignette, and then you do the motion blur. But yeah, you are talking before. You was talking about a CRT effect, right? I'm just talking now in general about post-processing. All right. So for that specific CRT effect that I use, and if you want to implement your own, you basically need 5 processing layers. First, we are doing a bloom threshold post-processor, which basically means that you have an image, and that we are picking up only the brightest points of that image, and then we applying a Gaussian blur on it. By the way, I'm saying that it's 5, and I forgot to mention it here, but it's 2 times. One for a Gaussian blur to the left, and one to the Gaussian blur to the right. Then we're doing a bloom composite, and that's basically combining everything together again with the normal render target and the blur. Otherwise, everything will be blurred, and that is not nice, because the darker spots you don't want to blur. Otherwise, you have no bloom, right? So, and then we're going to implement the actual CRT shader, which is, by the way, the CRT new Pixie post-processor, which is based on another open source project, which I converted to the Raylib OpenGL library. So it's compatible. Now comes a big surprise. And here we go. And basically, I decided to not go too much in technical depth in the video itself. Otherwise, you will see me constantly programming, coding, and that will be boring, right? Most of the people also prefer written text, so I decided to also make a written tutorial out of it. Then you can just do it in your own pace and implement it. But I just quickly wanted to show you all the things that I wrote. There is also an example, and the example I just quickly want to show you to you. So in here, I loaded in my example code, which is also available on the documentation to download. And if I'm now going to run this, there we go. Yes, it's very small, but you can see that the shader is applied. Everything is correctly loaded. All right. So if you are really interested in this CRT shader, or you want to have a full post-processing stack in your Raylib and your C# game project, then please use this. This is, by the way, open source, MIT licensed. And then I have written the full written tutorial for it that you can follow it on your own pace. But now at least you have a little bit of a grab how it basically works. All right, that's it. So basically, if you are interested in more of those things, then I'm going to weekly going to write a written tutorial. Then you're probably going to think, why should I then subscribe? And then just go to the website. I also going to cover it in my YouTube videos in combination with my game project. And also, I have some crazy plans for the Halloween. Yes, I know it's far away yet, but I have my arcade cabinets below, and I want to make some new games on it. So, and that's going to be yet again some specials. So, if you're interested in those, and I'm of course going to write those in C# and Raylib, then subscribe, and then I will see you the next time. Bye.